Okay, this differential equation is not in the form that we want it to be. Remember that the form that we're looking for to use Bernoulli's equation is dy dx. So this will be standard form plus p of x y equals f of x times y to the n. This is 1 over y squared. So we're just going to write this in standard form. So the first thing we're going to do is divide through by x. So dy dx plus 1 over x times y equals 1 over x, and 1 over y squared we're going to write as y to the minus 2. This is now in that standard form. So p of x is 1 over x, f of x is 1 over x, n is clearly minus 2. So the substitution we're going to use, u equals y to the 1 minus n, u equals y to the 1 minus 2. So that will be u equals y to the 3. Now, because the differential equation contains y, we just want to make y the subject here. So we're going to raise both sides to the power of a third. So y equals u to the third. We also have dy dx, and we're going to need to differentiate this expression, y equals u to the third, and then we need to use the chain rule as well to then have an expression for dy dx. So let's just start with dy du, which will be a third u to the third minus 1, so it'll be the expression, the exponent will be minus 2/3, and then using the chain rule, dy dx equals dy du times du dx. Okay, so let's substitute all of that into the differential equation. So we have dy dx, which is dy du times du dx. dy du is a third u to the minus 2/3. So third u to the minus 2/3 times du dx. So this expression here is the expression for dy dx, plus 1 over x times y, y is u to the third, equals 1 over x times y to the minus 2. So that will be y is u to the power of a third, and that's raised to the minus 2. So we have a third u to the minus 2/3 du dx plus 1 over x u to the third equals 1 over x u to the minus 2/3. Okay, we can clean this up by dividing through by u to the minus 2/3. So we're going to have a third du dx plus 1 over x u to the third. When you divide by u to the minus 2/3, you're really multiplying by u to the 2/3 equals 1 over x times u to the minus 2/3. Well, u to the minus 2/3 divided by u to the minus 2/3 is 1. So we don't actually have to write that in. So this expression u to the third times u to the 2/3 is just going to be 1, because we're going to add exponents. Multiplying powers of the same base. So a third plus 2/3 will be 3/3, which is 1. Sorry. This will reduce to u, not 1. So we have a third du dx plus 1 over x times u equals 1 over x. Now we just need to get this into a form where we can use variable separable. So du dx plus 3 over x u equals 3 over x. Du dx equals 3 over x minus 3 over x times u. Du dx equals 3 over x times 1 minus u. We can now separate these variables, so we divide both sides by 1 minus u, so we have 1 over 1 minus u du. At the same time, we're going to multiply by dx, both sides by dx. So we have 3 over x dx, and now we can integrate both sides of the equation. So 1 over 1 minus u will be ln 1 minus u, but we divide by the derivative of minus u, which is going to be negative 1. So we can really just write that negative out in front. And that equals, 3 is a constant, so it'll be 3 times the integral of 1 over x, which will just be ln x plus the integration constant. I can take this minus up here using log laws. So ln to the 1 minus u to the minus 1 equals ln, and similarly, we're going to just write this as ln x cubed plus c. Okay, we're going to drop the logs now. So we'll have 1 minus u, let's rather write this as 1 over 1 minus u, x cubed, rather it's going to be e to the ln x cubed plus c. So 1 over 1 minus u equals, I'm just going to split this expression up now into e to the ln x cubed times e to the c. E to the c is just another constant, so it's 1 over 1 minus u equals, we'll call that a. E to the c we'll just call a. E to the ln x cubed will just be x cubed. Okay, so just going to make u the subject of the formula now. So we'll have 1 over ax cubed equals 1 minus u, and then u equals 1 minus 1 over ax cubed, which we're going to write as 1 minus 1 over a. Really, we can just call it another constant. Let's just call it c. And then 1 over x cubed is x to the minus c. This is just a neater form. And then we need to obviously express this in terms of y, because we use the substitution. U equals y cubed, so therefore y cubed equals 1. Whether this is a minus c or a plus c, it makes no difference. Remember that c is an arbitrary constant, so we're going to make it a plus. It's just convention to do that. So the solution is y cubed equals 1 plus cx to the minus 3. Okay, this differential equation is not in standard form. So the first thing we're going to do is put it into standard form. So we'll start by multiplying y into the bracket. So we'll have x y to the 4 minus y on the right hand side. Then we're going to move the minus y across, dy dx plus y equals xy to the 4. So a differential equation of the Bernoulli form, the general form is dy dx plus p of x times y equals f of x times y to the n. So it's in this form. Now we have dy dx, the coefficient of y, which is p of x, is 1. F of x is x, p of x is 1, and we can clearly see that the value of n is 4, looking at the exponent of y to the 4. So n equals 4. So the substitution we're going to use is u equals y to the 1 minus n. So it's y to the 1 minus 4. So u equals y to the minus 3. Now we want this y to be the subject of this formula here. So y will be, we're going to raise that to the minus third. So y will be u to the minus a third. And since we have dy dx, we're going to need an expression for dy dx now in terms of u. So the first thing we do is differentiate dy y with respect to u. So finding dy du, which is minus a third u to the minus 2/3. Now dy dx using the chain rule equals dy du times du dx. So it's going to be minus a third u to the minus 4/3 du dx, and then we're going to substitute this expression into dy dx. So minus a third u to the minus 4/3 du dx plus y. Y is u to the minus a third equals x times y to the 4. Y is u to the minus a third, and that's raised to the power of 4. So we have minus a third u to the minus 4/3 du dx plus u to the minus a third equals x times u to the minus 4/3. Okay, we're now going to divide through by u to the minus 4/3. So we have minus a third du dx plus u to the minus a third times u to the 4/3 equals x. U to the minus 4/3 divided by u to the minus 4/3 is just going to be 1. So minus a third du dx plus this over here will give us just u. It will be u to the 4/3 plus minus a third, which is 3/3, which is just u to the 1, and that equals x. Just multiplying through by minus 3 now, we'll get du dx minus 3u equals minus 3x. Okay, this is now a linear differential equation. So we're going to need to find an integrating factor. So just to refresh your memory, that the general form of a linear differential equation is dy dx. Okay, we're using variables u and x here, but it makes no difference. Dy dx plus p of x y equals f of x. This is a linear differential equation, and the integrating factor is mu of x equals e to the integral of p of x dx. So we have this form here. We just are using the variable u as opposed to y. So p of x is minus 3 and f of x is minus 3x. So p of x equals minus 3. So the integrating factor, mu of x, will be e to the integral of minus 3 dx. That's e to the minus 3x. So this will be the integrating factor. We're now going to multiply the terms of the differential equation by this integrating factor. So we have e to the minus 3x du dx minus 3 e to the minus 3x u equals minus 3x e to the minus 3x. Now the left hand side reduces to the form d dx, the integrating factor minus 3x times u, and check this by differentiating this product e to the minus 3x times u. When you differentiate with respect to x, you'll have minus 3 e to the minus 3x times u, which is this term here. And then with respect to u, you'll have e to the minus 3x times du dx, which is this term over here. And that equals minus 3x e to the minus 3x. Okay, so integrating both sides, we have e to the minus 3x times u equals, minus 3 is a constant, so we'll just pull that out with the integration sign, times the integral of x times e to the minus 3x dx. Now, this integral we will solve by using integration of parts. Okay, so integrating by parts, we will let x be u. Now, don't confuse this u with the previous u. You can use another letter if it makes it easier. So u equals x, du equals dx. dv equals e to the minus 3x dx, which means that v equals e to the minus 3x divided by minus 3. So e to the minus 3x times u. Don't confuse this u with this u over here. Use a letter like t if you prefer to avoid any confusion. Equals minus 3 times uv, which will be minus a third x e to the minus 3x minus the integral of v du. So minus a third e to the minus 3x dx. So e to the minus 3x times u equals minus 3 times minus a third x e to the minus 3x plus a third times the integral of e to the minus 3x is e to the minus 3x divided by minus 3, and then you add the integration constant. So e to the minus 3x times u equals minus 3 times a third will just be 1, so it's x e to the minus 3x. We'll have minus 3 times minus a ninth, so we'll have plus a third e to the minus 3x, then minus 3 times c. We'll just write it for now as minus 3c. We can call this another constant, like another object constant like a, just to clean it up. So we'll have e to the minus 3x times u equals x e to the minus 3x plus a third e to the minus 3x plus a. And now we can divide each term by e to the minus 3x. Therefore, u equals x plus a third plus a e to the 3x. And u equals y to the minus 3. So therefore, y to the minus 3 equals x plus a third plus a e to the 3x. You can leave it in this form. You can leave the solution in that form. You can express y to the minus 3 as 1 over y to the 3 and then express the solution in terms of y, but this is also acceptable just to leave it in this form. This differential equation is not in standard form. Just recall that the standard form of the Bernoulli equation is dy dx plus p of x times y equals f of x times y to the n. So putting this into standard form, we're going to divide through by x squared. So dy dx minus 2 over x times y equals 3, and I'll write this as x to the minus 2 times y to the 4. So we can clearly see that minus 2 over x is p of x, and 3x to the minus 2 is f of x. The value of n in this case is 4, so we're going to use the substitution u equals y to the 1 minus n, so u will be y to the 1 minus 4. U is therefore y to the minus 3. Now I need to make y the subject of the formula here, so we're just going to raise both sides to the power of minus a third. So y equals u to the minus a third. We have this term dy dx, so we're going to use the chain rule here to find an expression involving only u and x. So we're going to differentiate y with respect to u. So dy du equals minus a third, u to the minus a third minus 1 is minus 4/3. Dy dx using the chain rule equals dy du times du dx. So therefore, dy dx will be minus a third u to the minus 4/3 times du dx minus 2 over x times y. Y is u to the minus a third, and that equals 3x to the minus 2 times y to the 4. Y is u to the minus a third. We raise that to the 4. Just to clean this up a bit. Now I'm going to divide through by u to the minus 4/3. So minus a third du dx minus 2 over x times u equals 3x to the minus 2. This is a linear differential equation, although it's not in standard form. So recall that standard form is dy dx plus p of x times y equals f of x. So we're just going to put this into standard form. So we're going to divide through by minus a third. Minus 2 divided by minus a third will be plus 6. So 6 over x times u equals 3 divided by minus a third is minus 9. And we'll leave that as x to the minus 2. This is now a linear differential equation in standard form. So 6 over x is the value of p of x, and minus 9x to the minus 2 is f of x. So we now need to establish the integrating factor, mu of x, which is defined as e to the integral of p of x dx. P of x is 6 over x, so the integrating factor equals e to the integral of 6 over x dx, which is e to the 6 times the integral of 1 over x dx, e to the 6 ln x. We're going to bring the 6 up here to the exponent position, so that equals e to the ln x to the 6. So the integrating factor mu of x equals x to the 6. We're now going to multiply every term of this differential equation by this integrating factor. So we have x to the 6 times du dx plus 6 over x times x to the 6 times u equals minus 9x to the minus 2 times x to the 6. Just cleaning that up a bit gives us x to the 6 du dx plus 6x to the 5 times u equals minus 9x to the 4. The left-hand side reduces to the form d dx plus x to the 6 times u. That equals minus 9x to the 4. Now I can integrate both sides with respect to x. So on the left we have x to the 6 times u equals minus 9 times the integral of x to the 4. And add 1 to 4, so we have x to the 5, and then we divide by 5, and then we add the integration constant. So x to the 6 times u equals minus 9 over 5 x to the 5 plus c. Then dividing through by x to the 6 gives us u equals minus 9 over 5 x to the minus 1 plus c x to the minus 6. Recall that u equals y to the minus 3. Therefore, y to the minus 3 equals minus 9 over 5 x to the minus 1 plus c x to the minus 6. And we can leave the solution in that form.